Hi everyone! In this video, we are going to tackle some applications of the similarities in a right triangle. These are discussed on your Student Learning Guide 7.5.2. From our class discussion, we know that if in a right triangle, the altitude to the hypotenuse is drawn, the following derived geometric means are true. First, the length of h, the altitude to the hypotenuse, is equal to the square root of the quantity m times n. Second, the length of leg A is equal to the geometric mean of the segment of the hypotenuse adjacent to it and the hypotenuse itself, or in our equation, we say that A is equal to the square root of the quantity m times the quantity m plus n. Third, the other leg B is equal to the square root of the quantity of n times the quantity of m plus n. For a detailed discussion of this, you may want to review the contents of your SLG 7.5.1. Let us apply these similarities in solving the problems in your SLG 7.5.2. Since the odd-numbered exercises are answered at the end of the learning guide, we will only use the even-numbered exercises in this video. The problem reads, in the figure, segment CD is the altitude to the hypotenuse of triangle ABC, and segment DE is the altitude to the hypotenuse of triangle ACD. The figure is not drawn to scale. We are also given the quantities B and R as 16 and 4 respectively, and we are going to find T. From the original triangle, we can extract the smaller triangle that involves the given B and R and the unknown T, and that is triangle CAD. In this triangle, B is the hypotenuse, T is the altitude drawn to the hypotenuse, and R is a segment of the hypotenuse. We know that T is equal to the square root of the quantity R times S. Since R is already known to be 4, we only need to find the value of S. Since B is equal to the sum of R and S, we can obtain S by subtracting R from B. That gives us 16 minus 4, or 12. Now that the value of both R and S are known, we can easily plug them into the equation T is equal to the square root of the quantity of R times S. This gives us T is equal to the square root of the quantity 4 times 12. Simplified further, this is 4 square root of 3. So, the length of the altitude T drawn to the hypotenuse is 4 square root of 3 units. Let's have one more practice problem. Let's do item number 4 from your SLG 7.5.2. The problem reads, in the figure, segment CD is the altitude to the hypotenuse of triangle ABC, and segment DE is the altitude to the hypotenuse of triangle ACD. The figure is not drawn to scale. We are now given R is equal to 4 and M is equal to 8, and we are going to find S. From the original triangle, we will again extract the triangle that involves R, M, and S. That still is triangle CAD. R and S are segments in its hypotenuse, and M is the leg adjacent to R. We know that M is equal to the geometric mean of the segment of the hypotenuse adjacent to it and the hypotenuse itself, or M is equal to the square root of the quantity R times the quantity R plus S. Since R is equal to 4 and M is equal to 8, we can easily plug them into the equation. Thus, we have 8 is equal to the square root of the quantity 4 times the quantity 4 plus S. Simplified further, that is 8 equals the square root of 4 times 4 is 16, and 4 times S is 4S. We can square both sides and we get 8 squared is 64, and the square root of 16 plus 4S squared is of course 16 plus 4S. 64 minus 16 is 48, and that is again equal to 4S. We divide both sides by 4 and we get S equals 12. Acknowledging my references for this video, the developers of GeoGebra, which I used to draw the figures, and the writer of SLG 7.5.2, Mr. Ray Giovanni L. Villamora of PSHS CVSC.